Hey guys, how you doing? I'm just gonna start working through, still on 4.4 here, U-Substitution. Just gonna do a couple different examples, some that are a little bit more challenging to do, but we're still gonna be doing the same process where we're looking for the U-term and then kind of working through the problem that way. So this is example 3 from the notes, and we're starting with letter C. So I see that I have a fraction, right? And I want to rewrite this so that I have everything on the same line with each other. Okay. So I'm going to bring the radical up to the top. Okay. And then instead of leaving it in the root form, I'm going to write it with an exponent. Okay. So this is going to become x times 2x squared minus 1 to the negative 1/3, right? It's negative because it was in the denominator originally, okay? All right, so by looking at this, it should be pretty obvious what your U-term would be, right? It's going to be inside the parentheses here, inside the exponent, okay? So I'm going to make U 2x squared minus 1, okay? And then the derivative of that is going to be just 4x dx, okay? So if you look at your problem, right, you have x dx, okay? So the only thing that you need to do to your du term is you just need to multiply that whole thing by 1/4. Okay, so this is now going to give me 1/4 du equals x dx. Okay, so now I can rewrite my problem. All right, so I'm going to put the 1/4 out front, and then I have my integral, and then u to the negative 1/3 du. Okay, so now we just need to find our antiderivative. So I'm going to keep 1/4 here, and then if I add 1 to my exponent, that's going to give me 2/3. So u to the 2/3 divided by 2/3 plus c. Okay. Now, if I'm dividing by 2/3, I'm really multiplying by 3/2, right? So this is 1/4 times 3/2 u to the 2/3 plus c. Okay. So if I multiply my fractions here, right, this is going to give me 3/8 u to the 2/3 plus c, right? And then the last thing that I have to do is I just have to plug the u term back in. So this is 3/8 2x squared minus 1 to the 2/3 plus c. And that is your final answer. Okay, so again, just remember it's a good idea to get everything on the same line with each other. So write everything on the same line. Okay, so moving on to the next one. All right, so you're dividing by pi now, right? Now, pi is not a variable. It's actually just a number, right? So instead of dividing by pi, I can actually be just multiplying by 1/pi, okay? So what this problem is the same thing as is 1/pi times x plus 1 times x squared plus 2x to the 1/3, okay? I have everything now on the same line with each other, right? Now, this number here, right, that's a constant term, okay? It's not a variable. You're not going to be integrating that, okay? So what you can do with that, right, is you can move the constant term and move it out front because you're not integrating it. You're not really worried about it, okay? So you can move that number right out front. So I can make that 1/pi integral of x plus 1 times x squared plus 2x to the 1/3. Okay. Now looking at what you have, right? What do you think is the more inside part? Okay. Now I have x plus 1 here, and that's only being raised to the first. And then I have x squared plus 2x to the 1/3. So this, because the x squared plus 2x is being raised to the 1/3, this is what I'm going to make as my u term. Okay. So u now is x squared plus 2x. Okay, and then du is going to be 2x plus 2 dx. Okay. Now looking at what you have, right? You have 2x plus 2, and then in your original, you have x plus 1. Okay. So what would you need to multiply 2x plus 2 by to get x plus 1? Okay. Now you should figure out that that should just be a half, right? Okay, so this is going to be 1/2 du. Now half of 2x, right, is just 1x, and then half of 2 is 1. Okay, so you're keeping everything the same now in your problem. Okay, so when you rewrite the equation now, okay, you have 1 over pi that was out there originally, and now you can put 1/2 out there as well. Okay, and then it's u to the 1/3 du. Okay, so 1 over pi times 1 over 2 is 1 over 2 pi. Okay, and then it's u to the 4/3 divided by 4/3 plus c. Okay, so this is 1 over 2 pi times 3 over 4 u to the 4/3 plus c. All right, so this gives me 3 over 8 pi u to the 4/3 plus c. Okay, and then all you have to do is just plug the u term back in. Okay, so this will be 3 over 8 pi x squared plus 2x to the 4/3 plus c. And then that is your final answer. Okay, so for letter E now, so this is sine cubed times cosine of x dx. Okay, now one way that you guys can rewrite this is make this sine of x cubed like that times cosine of x. Okay, so sine of x cubed is the same thing as sine cubed of x. It's just rewriting it in a different way. Okay, so it should be pretty obvious what your u term is going to be, right? So u is going to be just sine of x, okay, because that's inside the exponent. So then du becomes cosine of x dx, right? So remember our ladder that we have, so you got sine, cosine, negative sine, negative cosine, right? So if we're doing the derivative, we're going down a step on our ladder, okay? So very nicely, you already have cosine of x dx, so there's really no rewriting that you have to do when you work out the problem. Okay, so this becomes, instead of sine of x cubed, you can just make this u cubed du. Okay, so you add 1 to your exponent, divide by the new exponent, and then you can just plug back in. So this would be sine of x to the 4th over 4 plus c. Okay. And then for the last one, all right, so now we have an e to the x term. All right, so remember when we did derivatives, the derivative of e to the x, right, was just itself. Okay, and then, so that means that the antiderivative of e to the x is also just itself. Okay, pretty easy to remember. Now, anytime you're using e to the x, your u term, most of the time is going to be your exponent. So when using e to the x, the exponent will be your u term. Okay, so that's going to tell me that u should be 3x. Okay, so then du becomes 3 dx. Okay, now you should notice that you have 5 dx, right? So what would I need to multiply by so that I could get 5 dx from 3 dx? Okay, so 3 times something is going to give me 5, right? So then what you're going to be multiplying by is just 5/3, okay? So I'm going to take that number and I'm going to multiply it to my problem now. Okay, so you got 5/3 du equals 5 dx. Okay, so when you rewrite your problem now, you can put the 5/3 out front, okay, and then instead of 5 e to the 3x dx, you just have e to the u du, okay? And then again, if you look up with what we wrote at the beginning of the problem, right, antiderivative of e to the x is literally just itself plus c, okay? So that's what we're going to do again. So you got 5/3 e to the u plus c, okay? And then you just plug u back in. So 5/3 e to the 3x plus c. Okay. All right, so for number 4, all right, we're going to be rewriting. Okay, so I have x times x squared minus 4 to the negative first dx. Okay, because x squared minus 4 is in the denominator. All right, so my u term should be x squared minus 4. Okay, and then du would be 2x dx. All right, so I need to multiply both sides by 1/2 so that I get my x dx that I have in my original problem. So 1/2 du equals x dx. Okay, so I have 1/2 integral of u to the negative first du. Okay, now remember when we had talked about when you get u to the negative first, right? If you add 1 to your exponent, you're going to get u to the 0 over 0, right? Which doesn't exist. Okay, so anytime you're doing, something to the negative first power, this is then just going to become ln of x plus c. Okay. So in this case, u to the negative first is just going to become 1/2 of, and then ln of u plus c. All right, the antiderivative of something raised to the first power is ln of x. Okay, and then you're just going to replace with what you have as u. So x squared minus 4 plus c. Okay, so just something to be careful with if you're integrating something raised to the negative first power. Okay. All right, so the integral of something raised to the negative first power is ln of x, and then the derivative of ln of x then becomes 1 over x, or x to the negative first, right? Just working backwards. Okay, so for this one, right, you got 5 over x times ln of x to the negative first dx. Okay, so because the ln of x is being raised to the negative first, that's what I'm going to make as my u term here. So u is going to be ln of x. Okay, so the derivative, right, what we just talked about above, the derivative of ln of x is 1 over x. Okay, or x to the negative first. All right, so you have 1 over x dx. Okay, so what would you need to multiply everything by so that you get 5 over x dx? All right, so it should be pretty obvious that you just need to multiply it by 5, right? 5 times 1 over x would be 5 over x. So you get 5 du equals 5 over x dx. Okay, so you're going to put the 5 out front. All right, then you have u to the negative first du. Okay, so your antiderivative again of something raised to the negative first is ln of u. Okay, so this becomes 5 ln of u plus c, and then you just plug the u term back in for u. So you have 5 ln of x plus c. Okay, so these are just some different examples, using different functions that we've talked about throughout the year. Okay, so if you guys have any questions, let me know. Thanks.